When you picture a building coming down, what do you see? I bet it's a massive, chaotic explosion, right? Just dust and debris everywhere, a huge cloud of destruction, basically something straight out of an action movie.
But what if I told you that what looks like pure chaos is actually one of the most precise and controlled feats of engineering you could ever witness? Yeah, the reality is a world away from that myth. It's not about brute force at all, it's about strategic timing. And it's definitely not some chaotic explosion. It's a meticulously planned, controlled collapse.
Okay, so let's dive right into this. To really get how this all works, we first need to be on the same page with our terms. So, what exactly is a building implosion?
Here's the key. An implosion is a demolition technique where explosives are used to make a structure fall inwards on itself. The whole goal is surgical precision, to have it collapse vertically, as neatly as possible, right into its own footprint without bothering the world around it. Now, you don't just use this technique for any old building. This is the special forces of demolition. It's reserved for the big stuff, massive commercial buildings, aging industrial plants, or huge unsafe structures that need to come down, especially when they're crammed into a tight city block with neighbors just feet away.
So how in the world do they pull this off without damaging anything nearby? Well, it all comes down to this painstaking four-step process that takes a building from a standing blueprint to a tidy pile of rubble.
You can almost think of it like a four-act play. It starts with incredibly intense planning. Then it moves to the strategic placement of explosives. The climax, of course, is a perfectly timed detonation, and the entire thing is wrapped in an ironclad commitment to safety. Let's break down each act. So, step one is all about the homework. Long before any explosives show up, engineers basically become detectives. They analyze the building's every secret, its load-bearing columns, what it's made of, and exactly how close its neighbors are. Seriously, no two implosions are ever the same. Each plan is completely custom.
And this brings us to a huge misconception. The explosives aren't just slapped onto the outside to create a giant bang. No, small, precise charges are carefully placed at critical structural points inside the building. And here's the most important part. The explosives aren't there to blow the building up, they're there to surgically kick out its legs.
When it's time to set off those charges, the timing has to be absolutely flawless. We're talking about a level of precision where a tiny fraction of a second, just a blink, can be the difference between a clean collapse and a total disaster. In this world, milliseconds matter.
You see, the detonation itself is this carefully choreographed sequence, like a ballet of destruction. The charges on the lower supports go off first, which creates a void. This kicks off a chain reaction, pulling the rest of the building inward and causing the upper floors to just pancake straight down into the space that was just created below.
And finally, holding this entire operation together is step 4, an obsessive focus on safety. This means securing a huge perimeter, cutting all utilities to prevent any secondary fires or explosions, deploying really advanced dust control systems, and clearing wide evacuation zones. Nothing is more important.
So we've covered the how, which is amazing, but let's really focus on the why. Why go through all this painstaking effort for such an incredibly exact process?
I mean, all of this effort begs a really simple but incredibly important question. Why go to such extreme lengths for this level of precision?
Well, the answer is all about control. This incredible engineering precision is what ensures that buildings just a few feet away are left completely untouched. It also dramatically cuts down on cleanup time and cost, it's way better for the environment, and most importantly, it creates far, far safer conditions for everyone involved.
And this brings us to the final, and I think the most elegant idea in this whole process. Because the most powerful force at work here, well, it isn't the explosion at all.
This really gets to the heart of it all. The explosives are not the star of the show. Gravity is. You can think of the engineers and the demolition experts as choreographers. They aren't overpowering the building, they're just removing critical supports at the absolute perfect moment, allowing gravity to step in and do all the heavy lifting.
So what looks like this totally destructive spectacle is actually a beautiful dance with physics. It's just gravity, guided by design. Which, leaves us with a final thought to chew on. What other seemingly chaotic processes in our world are actually masterpieces of hidden engineering?